And here mathematically the expected square error of a prediction f hat of x is specified as like, kindly just observe, error which is equal to bias plus variance plus noise. And here aggregating the output, kindly just observe dear friends, for classification it would be the majority voting and for regression it would be the average. Dear friends, in simple term, this random forest is specified as like bagging with extra layer of randomness. Yes, randomness not only in the data but also in the future used to split each tree nodes. So let me just break into step by step. So here first of all we are just taking the step 1, the data preparation. So assume we have data set D with n rows and m features, 2 properties. So here we are not going to use only one tree. As for a random forest, we are just going to have multiple decision tree, and towards that we need 2 main properties. One is of course the bias, it is low bias, and when considering the variance, yes, it is a high variance. And in practice, this random forest shows low training error, that is low bias, and strong generalization. It's robust to outlier, noise, and irrelevant future. Happy morning, dear friends. Here's Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today in this session, we are going to discuss one of the most impactful and widely used idea in the world of machine learning, that is ensemble method. Yes, dear friends, we are just going to discuss its mathematical route to practical implementation like bagging, and of course we are going to add upon with random forest. Dear friends, let me just dive into towards the introduction. You need an important decision made, say choosing the best stock to invest in. Would you rely on a single advisor, or would you consult multiple experts and then combine their opinion to make a better choice? That's the idea behind ensemble learning. Yes, dear friends, combining multiple model or weak learners to produce a strong overall model. It's like forming a committee of minds rather than relying on a single one. So this technique improves prediction performance, generalization, and robustness in real world data where noise, complexity, and variance are high. And here ensemble method shine by reducing overfitting and improving stability. Dear friends, there are different type of ensemble techniques: bagging, boosting, and stacking. And in this session we will focus primarily on bagging and its implementation towards random forest. Back again, dear friends, ensemble technique or machine learning techniques that combines multiple base model and models to create an optimal predictive model. To comprehend this definition better, we need to take a step back and consider the ultimate objective of machine learning and model building. Yes, dear friends, in the previous session we have discussed about decision tree. By using decision tree, we have discussed to determine whether an individual should play golf outside in certain weather condition. The tree takes into account with various weather factors, and based on each factors, the tree either decide or ask another question. Kindly just observe, we have the weather condition as like outlook, temperature, humidity, and wind. And here towards the prediction whether to play golf outside, yes or no. And dear friends, for example, if it is overcast, towards outlook, if it overcast, the decision is to play outside. But if it is sunny or rainy, or even of course towards the wind, the tree asks further question before deciding whether or not to play. And towards this, to certain decision tree, we must consider what future we will use to make decision and what threshold we will use to classify each question as a yes or no answer. We can continue to add questions until we define the yes or no class. But what happened if we want to ask ourselves if we had friends to play with? Dear friends, if we have friends, we play every time. If not, we might continue to ask ourselves questions about the weather. And here, by adding an additional question, we hope to greater define the yes and no classes. But how we can do this? Here comes the exact ensemble technique. Using ensemble model allows us to take a sample of decision tree into account, determine whether future to use at each split, and make a final predictor based on the aggregation result of the sample decision tree. And dear friends, this approach is more reliable than relying on just one decision tree to make our final decision. Let's now understand the maths behind why ensemble works so well. Suppose we have some M independent model. So see here we have 4 different models: decision tree, Navier Bay, K nearest neighbor, and support vector machine. Let me just take an example as M number of independent models. Of course, each model has an error rate of epsilon. If their errors are uncorrelated, then combining them, say by averaging, helps cancel out individual errors. And this best understood via bias variance decomposition of error. And here I just want to specify what is a bias. Dear friends, bias is the error due to incorrect assumption in the learning algorithm. A model with high bias oversimplifies the target function. And here variance. Variance is the error due to excessive sensitivity to training data. And here high variance means the model learns noise as if it were signal, and classic overfitting. And next it comes the noise, which is the irreducible error. That is the randomness inherent in the data. And here mathematically the expected square error of a prediction f hat of x is specified as like, kindly just observe, error which is equal to bias plus variance plus noise. And dear friends, in ensemble learning, particularly bagging, particularly this bagging will reduce the variance without significantly increasing the bias. Now here is a beautiful insight. If we have m independent base learner and each with a variance as like sigma square, the variance of their average reduced to sigma square divided by m, which means the more independent models we have, the more stable our prediction becomes. This is why ensemble learning is so powerful. It lets us keep our model flexible and low bias, but counters their tendency to overfit by averaging or voting. Coming towards bagging. Dear friends, bagging also called as bootstrap aggregation, which works by training a dataset with multiple models to obtain more accurate output. This topic is particularly important as many companies are now using these techniques in their data analysis. Dear friends, suppose we have a particular problem statement and we have a dataset called D. In this particular dataset, we will create several base model as like M1, M2, M3 until Mn, and use them to create multiple base learner. For each model, we will provide a sample of dataset, and kindly just observe, node each dataset would be same. So here the sample of dataset that is less than the number of records in this dataset, and we are just passing it to the every model, and we will use row sampling with replacement for each model to provide the data. Dear friends, the same process will be repeated for the next models where we will resample the records and provide them to the model. And as specified, each model will have different set of data. After providing the data to the model, they will be trained on the data set. So this process will be repeated to all the models in this group. After completing the training, we will use new data from the test data set to make prediction. And for binary classification, of course, we will send test data D to the model 1, and if the model 1 provides the output 1, and kindly just observe, from model 2 we just get 0, model 3 we just get 1, and from model N the output is 1. We will use a voting classifier to combine all these output of the model for the test data here, and it is 1. The output with a majority of the vote will be considered. And kindly just observe, dear friends, by using the row sampling with replacement and a voting classifier, we will combine the output of the models for the final result. This is how bagging techniques work. And I just let you know the step-by-step process of this. Dear friends, here, the first of all, it is very much important which data we are going to use it. And next, again towards the bootstrapping of the data set. And we take multiple random sample for our data set with replacement. If we have a data set of n example, each sample will also be of size n. But some rows will appear multiple times while some may be left over. So this create a diverse subset of data, just like giving each model a slightly different view of reality, which I already specified. Yes, bootstrap samples, and here with row replacement, we are just forming this. And next, we are in need to train the weak learner, or we can just say train our base model. Dear friends, each bootstrap sample is used to train this base model. And of course, since the training is slightly different from each tree, they overfit differently. And this is good because their error won't be the same. And when on coming towards the output, of course, once all models are trained, we combine their predictions. And here, aggregating the output, kindly just observe, dear friends, for classification, it would be the majority voting, and for regression, it would be the average. And here, mathematically, the ensemble prediction y hat, which is specified as 1 by number of model, and here towards the summation of I1 to M and HI model prediction. And here, dear friends, bagging works like a democratic vote. Every model gets a say and the majority wins. So this reduces variance, enhances stability, and improves generalization. Okay. Now, the time is for important topic, random forest. Dear friends, the random forest algorithm, it's one of the most widely used and trusted algorithm in machine learning. The bootstrap random forest algorithm combines ensemble learning method with the decision tree framework to create multiple randomly drawn decision tree. Each and everything here, it would be a decision tree from the data, averaging the results to output a new result that often lead to prediction or classification. Okay, so let me just show some example to help us understand how random works. Dear friends, in bagging, we uses multiple base learner model, and such as decision tree 1, decision tree 2, 3, and till n. Okay, so let me take 4 models to discuss here. In random forest, we use decision tree for designing these models. We sample some rows and columns from the data set given. Dear friends, we use row sampling with replacement, which means we take some rows from the data set and pick some columns as a future sampling. This is how we use bagging to select a subset of rows for our decision tree. And here the number of records in decision tree will always be less than the records in the data set. And here I just want to specify one thing, dear friends. When we have a small number of records, so we designate some of them to be used for training. Then we take a sample for those records and give them to the first decision tree. And here the same process is repeated for second decision tree, but with replacement sampling. When we sample with replacement, not all records are repeated. Instead, a new sample is taken and given to the second decision tree. And here some records and futures may give repeated during this process, but many records are changed. This row and future sampling process is repeated for each decision tree with a different set of features being used each time. After training the decision tree on the given data, it can accurately predict the output for new test data. In a binary classification problem, if the decision tree gives 1 as a positive or 0 as a negative, and kindly just assume to make a final prediction, we use the majority vote of the models. And here, yes, of course, we just get output from one decision tree 1 as 1 and decision tree 2 as 2. Of course, we are not just going to stop with 1 and 2 trees. If we are having n number of trees, the majority vote would be assumed as our resultant. Difference in simple term, this random forest is specified as like bagging with extra layer of randomness. Yes, randomness not only in the data but also in the future used to split each tree nodes. So let me just break into step by step. So here, first of all, we are just taking the step 1, the data preparation. So assume we have data set D with n rows and m features. And the second step is to bootstrap. Dear friends, generate bootstrap samples as like D1, D2 till dm, each of size n using sampling with replacement, same as bagging. And here tree building with future randomness, that would be our step 3. So for each decision tree, dear friends, instead of evaluating all m future at every split, we randomly select m feature, typically where we just specify m is equal to root of this m number of model for classification. And then the best split is chosen for this m feature. And each tree is grown fully without pruning, and trees are deep and complex, but they overfit in different ways due to the data and feature randomness. And here, after making the prediction, yes, we are in need of the last step as aggregation. Yes, dear friends, of course, as I have already specified, for classification, yes, we just consider the majority voting, and for regression, we just take mean or median of this output. Dear friends, when we use multiple decision tree, we need to consider 2 properties. So here we are not going to use only one tree. As for a random forest, we are just going to have multiple decision tree, and towards that we need 2 main properties. One is, of course, the bias. It is low bias. And when considering the variance, yes, it is a high variance. Dear friends, actually, when we say a model has low bias and high variance, yeah, we are referring to how it behaves during learning and prediction. Yes, that is as like training and testing. And here this bias is the error that arises from overall implicit assumption in the learning algorithm, that is during training. So a low bias means the model fits the training data very well. It's flexible and captures the patterns accurately. But here's the trade-off: high variance. High variance means the model is very sensitive to fluctuation in the training data. It performs well on the training set, but might perform poorly on unseen data due to overfitting. That is on testing data. So, if we create a decision tree to its complete depth, it will have low bias and high variance, and it will get properly trained to our training data set. So, the training error will be low. A high variance occurs when a decision tree produces a large number of errors due to new test data. So this happens when the decision tree is created to its complete depth and known as overfitting. Dear friends, in random forest, multiple decision trees are used, each with high variance. However, when these decision trees are combined using majority vote, the high variance is converted to, kindly just observe, the high variance is converted to low variance. So this is achieved by using row and future sampling in dataset. By combining the output of multiple decisions, the high variance is reduced. And in practice, this random forest shows low training error, that is low bias and strong generalization. It's robust to outlier, noise and irrelevant future. And as a bonus, it gives future importance scores, helping with interpretability. So here is what the random forest often outperforms the plain bagging. Yes, dear friends, let I just give you the maths into the mix again. If the variance of a single decision tree, I have already specified, it is as like a sigma square, which is the variance. If trees are independent, variance reduces to as per number of models. So sigma square divided by number of model, that is number of independent model. But in reality, trees are correlated where in random forest, especially if they are similar feature. So actually the variance of this ensemble technique, kindly just observe, variance of ensemble, which is equal to rho times sigma squared plus 1 minus rho divided by number of independent model, that is multiple models, all multiplied by sigma squared. Dear friends, here this exact row is the correlation between tree prediction. And the random forest reduces this row by selecting random subset of the future. So tree learn different patterns, reducing overall variance even further. Now, if we have 1000 records of a data and we just changing 200 records, how will it impact the output? Dear friends, we are currently conducting row sampling and feature sampling for every decision tree and change this 200 records. This ensures that the 200 records are properly split between these decision tree. Some of the records will go to decision tree 1, decision tree 2, but this change will not significantly impact a decision tree's accuracy or output. This is due to the high variance property of random forest, which work well for most machine learning use case. And if this is a regression problem, yes, dear friends, the decision tree will give a continuous value and we can either take the mean or median of the output of a particular data set. And yes, dear friends, in random forest, the median of a particular output depends on the outputs distribution and the decision tree structure. Typically, random forest works by finding the average of the output across all decision tree. However, to reduce variance, we use multiple decision tree, row sampling, and feature sampling. And dear friends, random forest has both classifier and regression. The only difference between them is the classifiers use majority voting, while regression find mean or median of the output of all decision tree. By adjusting the hyperparameter, of course, I have to specify this. By adjusting hyperparameter is the number of decision tree. You can optimize the random forest performance. Yes, dear friends, thanks for watching this detailed breakdown on ensemble learning. I hope this gave you a clear and understanding of bagging and random forest. Dear friends, if you found this helpful, don't forget to like, share and subscribe to Demystify with Ajay for more deep dives into machine learning and artificial intelligence. Until next time, keep exploring and happy learning, dear friends.